Welcome to this instructional video on modeling multiplication equations using tape diagrams. And before you view this video, you should have viewed our previous videos on modeling addition equations using tape diagrams and modeling subtraction equations using tape diagrams parts 1 and 2. If you have already viewed those 3 videos, then you should already be well aware that there are 4 phases to creating these tape diagram models to represent these equations. And we'll just go ahead and begin solving these problems with our tape diagrams. So with our first example, we have example 5u, or appropriately read as 5 times u, which equals 45. And as always, we will start off by representing the value that the equation equals. And we know that this bar alone by itself has a value of 45. All by itself, it has a value of 45. And then we will draw a similar size tape diagram. And this tape diagram below 45 also has a value of 45 because they are the same size. The only difference, however, is that we want to have this equal 5 times u. So on the inside, we'll just go ahead and write this as 5u. Now, we have drawn a model to represent our problem, and we can go on to the second phase, which we will begin modifying this model to actually determine the value of our unknown. So we'll draw another tape diagram, and we will have one below it. We know both of these bars have a value of 45 if we're just talking about a numerical value. But now, instead of representing this second bar as 5 times u, understanding that this is a multiplication problem, we can also view this as an addition problem. If you think about what multiplication is repeated addition. So instead of just simply writing 5 times u inside of here again, I am going to break this tape diagram as best I can into 5 equal pieces. Remember, as best I can into 5 equal pieces. So we have 1, 2, 3, 4, 5 pieces, and each piece will have a value of u. And this also is equivalent to 5 times u. How do we know this? Remember, the definition of multiplication is repeated addition, and we see here u, if all of these pieces are combined, is being added to itself 5 times. That means u plus u plus u plus u plus u also will equal 5 times u. Now, since I broke my bottom bar up into 5 equal pieces, let's go ahead and break the top bar up into 5 equally sized pieces. Now remember, the whole thing numerically has a value of 45. But if we take 45 and break it up into 5 equally sized pieces, then that means this piece all by itself is 45 divided by 5. This is 45 divided by 5. Well, what does 45 divided by 5 have a value of? Think about that for a second. 45 divided by 5. What does that have a value of? I'll just go ahead and add this problem to the other pieces of our tape diagram. And each and every one, we're writing 45 divided by 5 because we have taken a total of 45 and it has been split into 5 equally sized parts. So we are just replicating 45 divided by 5 here. Now, once we have that, we can move on to dotting or making that dotted line to separate phase 2 from phase 3. And we can represent this relationship that we have just detailed here. Remember, the overall goal is just to find the value of u. Now we have 5 u's here. We really only need 1. We only need 1 u. So we'll have a tape diagram that is about equal in size to 1 u. And that tape diagram on top What's 45 divided by 5? Well, what does 45 divided by 5 have a value of? We can simplify that to 9. That can be simplified to 9, which means one single value of u, just one single value of u will have a value of 9. Now, moving on to phase 4, we want to check our solution. The original equation is 5u, or 5 times u, is equal to 45. If we are saying that u has a value of 9, then we would take out u using variable substitution and replace it with 9. 5 times 9 is equal to 45. 5 times 9 is equal to 45. Everything checks out. So that means the solution to our equation is u equals 9. Now let's go on to our second example, or sixth example rather. Example 6. 6b, or 6 times b, is equal to 18, and it is the exact same procedure as before. You go ahead and you draw your tape diagram, and you know that this bar will have a value of 18. You draw another similar size bar, and that will have a value of 6b, or 6 times b. And there is phase 1, which you have just completed. Now, moving on to phase 2. In phase 2, we are going to modify this. So we will replicate our bar in size. And now, instead of just simply writing 6b, I'm going to break 6b, that bar, up into 6 equally sized parts as best that I can. We're trying to modify this. We're just representing the idea of repeated addition being multiplication. So if we're going to break this up into 6 equally sized parts, instead of just writing it as 6 times b, we'll write b inside of each of these pieces of the tape diagram. And you should know that b added to itself 6 times still has the exact same value as 6 times b. And then we will break up our top portion. Top portion is being broken up into 6 equally sized parts, which means each part has a value of 18 divided by 3. Excuse me, not 3, 18 divided by 6. I'm jumping ahead of myself, getting ahead of myself here. So all of these, this one, the first piece, the second piece, all of them are all going to equal 18 divided by 6. And I'm just drawing arrows pointing. If you have seen me work out example 5, our first example with the multiplication equation, then you'll know that all of these will have 18 divided by 6 written inside of them. And now we can move on to phase 3, where we are going to represent this relationship with this expression in just one piece, or a single value of b, no more than that. And we will have this small piece of a tape diagram which had a value of 18 divided by 6. 18 divided by 6 is equal to 3. So now we can say that b is equal to 3. b is equal to 3 based off of our findings. And we will go ahead and check that solution using variable substitution. The original equation is 6 times b is equal to 18. You take out that 18 and replace it, you take out b and replace it with 3, and then you do 6 times 3. 6 times 3 equals 18. That checks out. So we know our solution is definitely b equals 3. And this has been modeling multiplication equations using tape diagrams.